Good morning. So this is my 8th lecture in this series. Today I am going to introduce you the definition of data wrangling, what are the tasks involved in the data wrangling process, what is the importance of data wrangling process. So this is the outline. Before that, we discuss about something called data preparation. So we start with data preparation, then we introduce the data wrangling process and the steps involved in it. Tasks or steps, they are same. So this is what is the 80-20 rule of data wrangling, a popular rule in the data wrangling. Here, basically, let us not worry about the name because I have not introduced you what is data wrangling here. So this is 80-20 rule. This I will discuss in the next slide. So what is data preparation? So data preparation is basically preparing the data for analysis. Why you need data? Because we want to analyze the data. Why we store data? Why you collect data? Why we do experiments? All these things basically to meant for some kind of analysis, some kind of study, some kind of evaluating something. So this is that is the prime reason because of which we are interested in the data. Okay. Now, if I collect the data in an experiment, or if I take data from somebody, or from online, or from some data sets, they may not be readily usable. So you have to prepare the data and keep it in the right format and to suit to your purpose, because you only know the purpose of your data analysis, the what purpose you are going to use this data. It is known only to you. So it is task specific basically. So you have to prepare the data every time. You have to prepare the data. If you have already prepared the data to some extent, you have to really make it convert into or transform into different format or different precision or different structure, for example. Okay, so you have to prepare the data basically to make it analyzable in a better way. Okay, and straightforward analysis you can apply only after the preparation of this data. Okay, that's why this data preparation task accounts for about 80% of the work of data scientists or data engineers and any kind of analysts basically. So here, this is what is the statement which I took from this source. This is from ResearchGate. There is you can go through this link where this is stated there, and this is shown here as a chart here, annular chart here. Here, if you see the list here, what data scientist spends most time doing. So 3% of the time, the data scientist will be building the training data sets, and 60% of the time in cleaning, organizing the data and cleaning the data. Okay. Then 19% the data scientist spends in collecting the data sets, and 9% in pattern mining or pattern recognition or basically pattern mining. Okay, data patterns. Then 4% in refining the algorithms. That means whatever algorithms you have applied here, you have to refine it. So, and others, some miscellaneous things are there. So they account for the 5%. So if you see here, most of the time we are spending here cleaning and organizing the data, 60%, and building the training sets, of course. This is again not a part of analysis, because you are preparing the data, you are making the data sets for training purpose and testing purpose, and this is outside the analysis basically. And I don't know whether we can really include this in the definitely for data preparation you can call it as a data preparation. if you cannot call it as a cleaning the data and organizing data is 60%, and building the data sets, training data sets or testing data sets 3%, like that it is shown. So overall, it was told that 80% of the work goes into the preparatory work rather than direct analysis using some mathematical algorithms. So mathematical algorithms only account for 9 plus 4, 13%. So you can say 15%, or you can even say 20%, but the remaining part is other than the analysis. Okay. So that's why this 80-20 rule has come. Probably it has come because of from the experiences of the data scientists from certain circuits. Okay. So now, what is cleaning, organizing the data? So other than the analysis purpose, what are the tasks involved with that one? Those things we can club under data wrangling. So data wrangling means it is not just cleaning the data, it has some more tasks also along with that one. Okay, it is, you can say, the rest of the analysis part. Here, so I have prepared the statement in my own way, considering several definitions available online. So I state the data wrangling is the process of cleaning, structuring, and enriching raw data into desirable format for better decision making in less time. So if you see it here, what are the things involved here? Cleaning, structuring, and enriching the data. So we will see what do we mean by enriching the raw data and into desired format and for better decision making. So after analysis, basically analysis is meant for decision making. You have to evaluate, you have to analyze the thing, you have to extract the knowledge, and you have to take information and knowledge. Then you have to take some decisions. And that decisions also, they are time bound. You cannot afford to take infinite time. So you have to take within certain time limits. So that is more important here. Okay. So what are the three things here involved? Structuring the data, formatting the data in the proper way, that is the functionality. Then the desired format is one thing. Then the decision making in less time. There are the decision making is their third point. Fourth point is in less time. So there are 4 parameters involved in this data wrangling, which drives the data wrangling. That is the functionality part, what it does, and what kind of formats we need, and what kind of decisions we make, and how much time we take for this. So this data wrangling, it involves 4 functional components basically. Now, these are the steps, and again I took from this website, Have Data, and you can go through this, and very nicely written here. Probably maybe this division of 6 may become 7 or 8 or 4 or 5. It depends on you how you take it, because some kind of overlappings are also there in this. Maybe if you can in a better way tune it, it can be 4 to 8, something like that. It need not be exactly the way, but I took directly from this website. So these are the things are projected there. So what are these steps? Let us see. First one is data discovery, data structuring. Second one, third one is data cleaning, data enriching, data validating, data publishing. So broadly, this is what is data discovery. So you have to discover the data. That means it is not the pattern discover. It is not the discovery of patterns. If the discovery of pattern is done, every analysis is complete. So it is not the discovery of that one. So data discovery, basically you are not, data is available and you want to understand more about the data. Discovering means what kind of data is, what are the missing values, what are the shortcomings or limitations of the data, all those things you have to discover. First, you should know some background about the data. Without that one, you cannot directly use that data. Okay. Then data structuring. So this data, raw data, it should be structured in a better way. Okay. This kind of structuring is useful if you want to, the data to be used by others also. You cannot just say you cannot have your own format and you can still have, but the utility of the data will increase if you structure globally accepted manner so that many other institutions or groups of researchers can use the same data, okay, for their purpose. Then data cleaning. And this is straightforward. The name itself indicates that you have to clean the data. When you take the raw data, naturally you need some kind of cleaning there. Some unnecessary data will be there. Some bad data will be there. You can call it as a junk data. So you have to clean it. Then after cleaning, you have the enriching. So enriching means, so after cleaning, it is not that the leftover data, the remnant data is directly usable. You have to really enriching this one. Probably I will go deep into this one at appropriate time later. And data validating. Now, see, when you get the data, it is a verification basically. Whenever you do one thing, again you verify whether let us say you have answered some question in the examination. So at the end of the examination, I mean just before 5 minutes or 10 minutes, you have to go through all answers, whether any skippages are there, I mean whether the answer is in fact referring to the asked question or any errors are there, like that. So once you do this testing and validation, basically people from industry, they are well aware of testing and validation, testing of something and validating the test results. You have to validate the results. It's in the same way here, you have to validate the data. Whatever you have prepared the data till the step 4, is it really useful? Okay, how much it is useful? So you have to validate the data, and probably some more steps you need at this point of time, either to transform the data, some kind of things, and maybe some format. Again, there may be some format changes also at this point of time, and you have to validate basically whether the data is valid or not, whether I can use this data for further analysis or not. I should not take some data which adversely affects my analysis. Okay, that's why you have to, is a very, very important step actually. It is something like a quality control in an industry. So you may have at divisions production and assembly and testing, and final is the quality control. So all these steps are something like steps in the industry, and this is the validation. Ultimately, it is a quality control. Whatever you have done earlier, you are finally checking everything, and after this, you will be releasing the data, that is publishing the data to the public or to your clients or to your researchers, so that they can use the validated data. So this after this point of time, no need to validate this data. So you are stamping the data. You are stamping the data that this is a valid data. You are committing to other people in the community that this data safely can be used for the purpose of your research or business purpose, any kind of analysis. Now, let us go to step by step. First, what is data discovery? The goal is to compile the disparate and siloed data sources. Siloed databases. Okay. So this is isolated databases. Disparate means separated. This is also same meaning, isolated. Independent, I can say, which is not dependent on others. Okay. So this is the goal, is to compile the disparate and siloed data sources, configuring each of them so that they can be understood and examined to find patterns and trends in the data. Okay, so these are patterns means any kind of pattern, and trends means it is basically linear, any linear relations among the data. Okay, this comes later basically. This is the afterwards which we are going to do anyway. But the goal is to compile the disparate and siloed data sources, configuring each of them. Okay, so this is more important here. Disparate means data collected from different sources. They are distinct, they are independent, and maybe physically, geographically at different locations also. And siloid means this is again isolated, same thing. Disparate and isolated, both are almost same. So these are the sources you are going to combine. Maybe one may be, for example, if you take the biomedical data, it has one-dimensional data, it has two-dimensional data, it has three-dimensional data. So one-dimensional data, if we take ECG, electrocardiogram, and EEG, electroencephalogram. So these are one-dimensional data. Two-dimensional means you can consider it as you can consider X-rays and other any kind of other medical images. They come under this. Still images, pictures, they come under this two-dimensional. And one is the one-dimensional data, other one is two-dimensional data, and third one is three-dimensional data. In three-dimensional data, you can take fMRI images. Three-dimensional, not fMRI, MRI images you can take. This is three-dimensional data. When you take three-dimensional data in time also as a frame, three-dimensional frames, then it becomes 4 dimensions. The fourth dimension is the time. So what is happening here? Different instruments collected the different physical parameters in different ways. Okay, so there is no correlation between the X-ray and blood test results or some urine test results. So there is oxygen levels or whatever you call different parameters. So there is no relation among these. The sources are different, causes are different, the formats are different. So now you have to take this and you have to first identify what kind of data these are, what are the data sources, what is the physics behind it. So then only you can say in the next step, future steps, you can understand what kind of what kind of processing you need to this one. Okay, so that's why it is like a it is something like reading like a novel and trying to understand the peripherals of the summary of the novel basically. Okay, so you are not going to take any of the steps here to process. It is only understanding the data basically. Okay, you are not taking any steps other than reading, understanding, and you are not acting anything on that one. The acting comes in the next step. Now, data structuring. The raw data comes in a wide variety of formats and sizes. And if I take unstructured data, speech data, it has uncompressed format, PCM, pulse coded modulation, PCM format, uncompressed, that is 16-bit, each sample 16 bits. And if I take same data, some other data, same speech again, you may use only 10 bits or you may use only 8 bits. Okay. Similarly, when you take an image, different sizes may be there. In images, small size images are there, big size images are there, and different, because when you are acquiring probably, you may not be acquiring the pure raw data, that means uncompressed data. Sometimes because of the huge data size, probably you must have compressed. Let us say you wanted something analyzed, but it may be in the JPEG compressed format. But still, as far as you are concerned, it is a raw data for you. Okay, and the JPEG compression, whatever compression is there, it is expected that you are not losing any of the data by the compression. Okay, so for you it is a raw data, and sometimes we are not worried about that. And we have the TIFF format, uncompressed formats like TIFF. So there you have the full size. That means 10 times more than the JPEG size. That is the original raw data, uncompressed data. So when you take, I can go on discussing these formats and sizes for long. So, but the idea is not, it won't suit here. So that's why, so you should understand that there are wide variety of formats and sizes. Sometimes use 1 byte per sample, sometimes use 2 bytes, sometimes use 4 bytes. So like that. Okay. And the raw data has no definite structure. It is not the structured data because it has just arrived from an experiment. You have recorded the data. It is something like a logbook. You have noted down the raw data there, and afterwards what to do with this data, you will decide later. Okay. So that's why you, at this point of time, you are not aware what kind of structure it has. And the structure, maybe somebody else will decide, or sometimes you may supply this data, raw data to some others. Those people, they take this raw data and they structure this in their own way. Okay. And if you want to do it, so based on your next step, you have to define the structure. Okay. So that the structuring happens in this case. Okay. Which means that it lacks an existing model and it is completely disorganized. It's just a normal statement. And I already explained this one. Then it needs to be restructured to fit in with the analytical model deployed by the business organization. It can be business organization or it can be an academic institution for research purpose. So it can be anything. Basically, it is to be restructured to fit into the analytical model. So you are going to develop an analytical model. So that it has to fit into the model needs certain kind of parameters which are to be stored in a structured form or in a proper formatted form. So this is what is the structuring will take place here. Then giving a structure to the raw data allows better analysis. The purpose of the structuring is better analysis because the model wants in that way, in that structure only it considers. So, and you are then because your analysis algorithms are, for example, if you need certain parameters, you put all the parameters as a structure. You have to initialize that structure, and it can be C language or it can be any object-oriented language. Then you have to initialize the objects there. So this is you need a structure. So same structure, whatever your language uses, this raw data must be converted into this structure. Otherwise, you cannot use data analytical tools which are used in that language. Okay. Then unstructured data is often text heavy. So mostly, if it is numerical data, definitely there will be some structure because numerical data means maybe 2 bytes. For example, when I say 2 bytes is one sample value, 2 bytes is one single value. First 2 bytes, next 2 bytes, like that. There is already built-in structure in that one. If it is only numerical values, but if numerical values, some text, some sentences, some paragraphs, so that kind of things. If you take their unstructured data, because they are not numerical values which are collected in the experiments. Okay, maybe you have taken from the unlimited sources, something like YouTube or some newspapers, and you have taken these sentences. So these are all unstructured data. Basically, it is a text heavy. Most of the times, unstructured data means text heavy. But nowadays, I think you need not feel that it is a text heavy. It is more video heavy, audio heavy, I should say. Okay, I think because audio books are there, for example. Now, in place of textbooks, you have the audio books, and you have the many video sources, and we follow videos. Okay, even for study purpose also nowadays, the learner is more interested, he or she more interested to see the YouTube videos before the examination. Okay, that is what I have seen. Several of my students, they do this. So I don't know really, this text heavy, maybe at some point of time it was there, but now we cannot authentically say that it is text heavy. It is basically unstructured data means it is, I should say, media, audio and video, audio visual heavy, I should say, and contains things such as dates, numbers. Again, the moment you say that dates and numbers, all this is all text, but this is also there still. But along with the text heavy, other formats are also there, evolved as important sources nowadays. Okay, such a raw data set needs to be parsed. So this is to be parsing. So what is parsing? We will see. Because basically any unstructured data to be parsed. Okay, that is what is told here. What is parsing? The raw data comes in a wide range of formats and sizes. The raw data has no definite structure. Okay, this is I think same thing, the same slide. This is yeah. Basically, I think so. What I say is, let us go to this parsing. So basically, I will explain this because it is just a simple thing. When you take Excel file, you open. I have given in the previous lecture some examples. You take a CSV file, open it with Notepad. You will see commas there. Okay, and it may be the delimiter, may be something else. So whatever between the values, whatever are there, they are to be parsed. Okay, that means I mean, how I should say, it has every file has a header there. You have to remove the header, and the data is not directly available. You have to peel the data. If you take a fruit, you have to peel the skin and take the actual fruit inside. So in the same way, when you take a JPEG file, for example, image file, or you take a TIFF file, it has some header, and around sometimes it as big as 1000 bytes will be there. So it is the source of the data, who is the owner of the data, where the data is recorded, all that information, metadata I should say. So it has a lot of metadata, and even the characters used to store numerical values also, they use different characters. Okay, so that's why you have to parse the data, means you have to extract the data, removing all the metadata information and all the unnecessary characters in the data. So that is called parsing. And in the same way, in the PDF also, portable document file also, you have format also, you have the same header. If you take PNG, portable network graphics, it is an image file, and GIF file, it is a small animation file. So you can, nowadays you get GIF is there, graphic interface format. So all this, any file you take, any data file you take, because finally you have to store it. Raw data means it is not that directly list of values or list of words. Okay, because even in the experiments also, you have to store it as a data file. So you have to store it in a file, and that file has the header, that file has certain unnecessary characters. If you take even speech, if you take, and you have the wave file, wave formats. Okay, it is uncompressed format. Of course, some compression formats are also available. So when you consider the raw data, we generally store it as uncompressed format, the audio data or speech data. That is what is wave format, and wave format we call it as a raw data. So that file, when you open the file, and you need a parser. Otherwise, that also contains some some extra additional characters or additional data which won't actually belong to the data. Okay, that is called parsing. Now, data cleaning. So here, this is the most important part, as you have seen in that chart. Is it makes 60% the cleaning part, and here cleaning means, further some more steps are there. So let us see the cleaning in this context. Data wrangling and data cleaning are two different processes basically. First is to say, as I told, we are studying the definition of data wrangling process. Okay, what are the steps involved in the data wrangling process? Data cleaning is a part of data wrangling. It is one task, one of the tasks in the data wrangling. And general in textbooks or in many of the sources, they combine these two. Wrangling, we also use interchangeably the word cleaning and data wrangling, but actually data wrangling is a bigger process in which data cleaning is a subtask in that one. Okay, and cleaning is just a single aspect of the complex data wrangling process. Okay, this is what I told. And for most part, raw data comes with a lot of errors that must be cleaned before the data can move to the next stage. Okay, so this is understood. Data cleaning involves tackling outliers. So this is the very most important thing in the analysis. and is not a part of analysis, you have to prepare the data. You have to remove the outliers. If you use outliers means all data, most of the data is following something, and outside that range, there is some value, one or two values are there outside. For example, if you take age maybe 1 year to, let us say 1 year to 110 years or 120 years, you can take, okay, technically. Then if somebody says 1200, 120, instead of 120, you have written 1200. So 0 has entered extra. So it is an outlier, okay, because you don't find any person with age of 1200, okay, 1200 age doesn't exist, okay. So that's why it is an outlier. And making corrections, sometimes you have to, maybe spelling corrections you have to make, and sometimes in one field, one time used, let us say, let us say data, for example. At some point you have used the DATA, sometimes you have used the DA, TAA or DAATA, something like that, okay. So that kind of corrections you have to do. Deleting the bad data completely. Some junk data is available, some question marks, some hash, some special symbols, something which are in the extended ASCII characters. Most of the times, extended ASCII characters, of course, they are available, but even within the ASCII characters also, they are not alphabets, they are not numericals, they are something special characters, that kind of things. Okay, that generally we consider it as a bad data. But you should be very careful what is bad data, because when you talk something, in one of the data you may have percentages, for example, percentage of marks. So sometimes you put percentage symbol there. So you should not treat that percentage as a bad data. So you should be very careful when you decide. So a lot of discretion is needed to decide what is bad data. So that is the main purpose of the first step, data discovery. So you open the data and you see the data visually also. You see the data, what kind of characters are there, what kind of fields are, what kind of values are there. So is it, so that to carry out the data cleaning process successfully, you have to discover the data, as I told in the first step. Okay, so this is how the cleaning is done. This is done by applying algorithms to tidy up and sanitize the data set. So you are basically, these errors, they are all something like so to simplify the data. It's a complex data, tidy data, simplest data, reduce the complexity, easily readable, and sanitize the data. It has something like some viruses in the sense, not soft, these viruses, the data set which is not falling into the data set, we can call it as some kind of, I'm calling it as virus. You have to sanitize that one, okay. So you have to remove the, what it means is you have to remove the invalid data, junk data from this data set, okay. So that is what you are doing in this cleaning process, okay. I think, so this one again I took from this link. You please go through that link. It has some other information, very useful information also. So I think let us discuss the next point in my next lecture. I will continue this lecture after this. Thank you for your attention.
Like, share and subscribe. Hit the bell icon for more updates.